Hello everyone. In this video, I'll be discussing what is meant by logarithms. So let's see why we study logarithms. So there are many reasons, but I'll be discussing just two of them. So the first reason is it helps in finding the index. So what is meant by index? Let's say if we write 10 raised to the power 1, this is equal to 10. Whereas if I take 10 raised to the power 2, this is equal to 100. So the power is also known as the index. So in the first case, the index is 1. In the second case, the index is 2. Let's say if I have something of this kind, 10 raised to the power x equals 50. So is there any integer or fractional value of x which you can use directly to calculate what should be raised to the power of 10 to get 50? We say it's tedious, it's not that easy. Say 50 lies in between 10 and 100. So we can say the power x, as the base is same, the x should lie in between 1 and 2. We can conclude only this much. Whereas logarithm helps in finding the exact value, and we will be going through how we find the value of x in this session. So the other reason why we use logarithm is it helps in representing large numbers. One of the example is it helps in representing the pH value of liquids, which you study in chemistry. pH value is the number of hydrogen ion concentration in a given solution. Now let's move on to how do we convert an exponential equation into a logarithmic equation. Let's say we have 10 raised to the power x equals 50. So here we say this is the exponential equation. We can say the x over here represents the index, 10 represents the base, and 50 represents the answer or the output. Now if we convert this into logarithmic form, it looks something like this. X will be equal to log 50 base 10. This is our logarithmic equation or logarithmic form. Now here what is meant by x? X, which was the index in the exponential form, becomes the answer. The base that was 10, that remains as the base of the logarithm, and 50 is the input to the logarithm, right? So this is the logarithmic form. So in general, we can say that if I have y equals a raised to the power x, then the corresponding logarithmic equation will be x equals log y base a. It's read as x equal log y base a, right? Now let's move on to how to convert back the logarithmic form into the exponential form. So now we have a logarithmic equation, that is log 3 base 2 equals x. So what do we have over here? Here x represents the answer, 2 represents the base of the logarithm, and 3 represents the input to the logarithm. Now the corresponding exponential form of this equation looks something like this. 2 raised to the power x equals 3. So this is our exponential form. Now what does x represent over here? So x, which was the answer in the previous case, now it represents the index, and 2, which was the base of the logarithm, is still known as the base, and 3, that was the input to the logarithm, is now the answer. So in general we can say x equals, if I take a logarithmic equation, x equals log y base a, then its corresponding exponential form will be y equals a raised to the power x. Yes, it's read as x equals log y base a and its respective exponential form is y equals a raised to the power x. So if we take an example over here as 2 raised to the power 3 equal 8. Now if we represent this in logarithmic form, it looks something like this. Log of 8, that is the answer. Log of 8 base is 2. Log of 8 base 2 will be equal to 3. So you say the base becomes the base of the logarithm. The index becomes the answer in case of logarithm. And the answer is taken as the input to the logarithm. Right? So this is true for all the cases. Now let's solve the problem based on this. So here it's given log a base 2 equals x and log b base 64 equal y. And also it's given a by b is equal to 2 raised to the power c. Express c in terms of x and y. So from the given equation I can write log of a base 2 equals x. Now the exponential form of this will be 2 raised to the power x equals a. The base raised to the power answer will be equal to the input of the logarithm. Right? So you can consider this as equation 1. Whereas log b base 64, so I can write log of b base 64 equals y. So its exponential form will be 64 raised to the power y equals b. Let this be equation 2. Now 64, you know 64 can be represented in terms of power of 2. So I can write this as 2 raised to the power 6 raised to the power y equal b, which can be also written as 2 raised to the power 6y equal b. Now this is my equation 2 only in the simplified form. Now if we use this condition, a by b equals 2 raised to the power c, what do you get? In place of a, I'll substitute 2 to the power x. So a by b is equal to 2 raised to the power x over 2 raised to the power 6y, and this can be written as 2 raised to the power x minus 6y. And it's given that a by b is equal to 2 raised to the power c, so I can write this is equal to 2 raised to the power c. So if I consider just this much, you can say as the base are same, the powers can be equated. So you get c equal x minus 6y. So I hope this video was helpful to you. Please subscribe to my channel to get the latest videos on logarithms.